Alright, here is my third and final video on linear regression. So here's part 3 where we're dealing with residuals. See the other videos if you want more information on this part, or these prior parts. So residuals, first of all, what is a residual? Residual of an observation is kind of the observed y value minus the expected y value. Sometimes you'll see that written as y minus y hat, because y hat is kind of what we expected from our linear regression line, and y is what we actually observed. So what I mean by that, okay, so when we left off, we had our scatter plot here and our linear regression line. I can trace some of these values, and let's find one to pick on. Maybe this guy here, when x equals 3, y equals 20. So let's look at this line right here. So what this is saying is that I observed 20 accidents. But I didn't expect 20 accidents. What I expected is whatever the height of the line is at that point. In other words, I expected whatever y hat is when x equals 3. And as you can kind of see, that line falls below this observation. So I expected less. In other words, my y hat is less than my y. I don't know exactly what my y hat is, but I'm going to show you how to calculate that. But the point is that because this line is below that blinking observation, I expected less than 20 accidents. So y minus y hat will be a positive number, meaning there were more accidents than I expected. Observed 20 accidents, expected less than 20. And then I'll say because y hat was less than 20, so my residual is positive. My residual maybe is positive. The residual for this observation. But if we pick on a different observation, maybe this guy down here, oh, there it is, when x equals 5, y equals 21. So this guy right here, it looks like the observation is below the line that indicates how many I expected. So in this case, expected minus observed, or sorry, observed minus expected would be a negative value. There were less accidents than I predicted. So how you can calculate your residual is y minus y hat. Maybe we'll do it for this one. We have, so residual, which is y minus y hat, is equal to 20 was my y value. I got to figure out what my y hat is. But I can figure out what y hat is because I already know from earlier what my linear regression line was. If I quit out of here, I still have this linear regression line from earlier. I figured out that my linear regression line was 4.3x plus 2.8. So what this line does is it says for any x value, in this case 3, I can figure out how many accidents I expect. So 4.3 times 3 is 12.9, and 12.9 plus 2.8 is what, 15.7? I think that's right. Maybe I should write that on the other side. So what happened there is we only expected 15.7 car accidents, but there were 20. 20 minus 15.7 is 4.3. So my residual will be equal to, my residual for this observation is 4.3. Meaning there were 4.3 more accidents than I expected. So that's just kind of talking about what a residual is and looking at one residual. If you want to see all of your residuals, to see all residuals, the residual of each of these observations, we can create a residual plot. And the nice thing is the way you do it is just like a scatter plot. Except for our y list, we're going to enter resid. So what I mean by that is, okay, to create our scatter plot, we went under stat plots here. So we hit second and then y equals. Sorry, second and then y equals. And we went under our first stat plot, we turned it on, and we created a scatter plot. And since L1 were where my x values were, I put L1 here. And L2 is where my y values are, I put L2. But now I don't want L2 to be my y values, I want the residuals to be my y values. So the way you can get your residuals in here is if, maybe I should say this. This is under second, it's under list, which is second and then stat. So right here where it's asking me for my y list, I'm going to hit second key, and then I'm going to hit stat, and then the seventh thing on this list is resid. So now what happens is it's saying, all right, for your x's, use your x values. For your y's, list the residuals. So now I've done everything I need to create my residual plot. A couple of minor points we're going to want to, maybe I'll say, make sure to re-zoom. And you probably also want to turn off your regression line. So earlier we showed how to graph a regression line on top of our scatter plot. We saved it under y equals. So if I hit y equals here, what happens is it lists my regression line. But I don't want to see that anymore because that's not going to make sense under my residual plot. So what I want to do is unhighlight this equals sign. I want to go over to the equals sign with my cursor and hit enter. And now what you'll notice is the equal sign is no longer highlighted, so I've turned off my regression line. And then rezoom. What I mean by that is if you hit yours, we want to change our window. We want a different window for the residual plot than we want it for the scatter plot. So if you hit zoom and then zoom stat, it'll rezoom and show you your residual plot, which looks something like this. So what this is saying, if I hit trace, is that I have all these observations, this one in particular, my x value equals 3 and my residual was 2.3. Let's see, there should be one in here where my x value is 3 and my residual is 4.3. That's this guy. So I can kind of scroll through and look at all of them, but I'm going to highlight this one up top because this is the guy we looked at earlier. What this is saying is there is an observation whose x value was 3 and whose residual was 4.3. That's exactly the observation we looked at earlier. That's this guy here. So he shows up above the line because his residual was positive. But as you can see, we have some residuals that are positive and some that are negative. And there doesn't appear to be much of a pattern going on here with the residuals. They're kind of randomly placed throughout, which is good. You want your residuals to be completely without a pattern. If you have a pattern, that can indicate a couple things, something called patterned residuals and something else called heteroscedasticity. But I think that's a little bit more than I want to talk about for this video. Is it 8 minutes? Okay, maybe I'll talk about that briefly. So here's how you view all your residuals. This is what's called a residual plot. You can look at any specific observation, but that's basically everything we have. And then I'm going to add two more things. When looking at residual plot, two things to observe. What was I talking about here? When looking at your residual plot, there's kind of two things to look for. The first one is if your residual plot looks like, I don't know, how do I say this? Let's say if it looks like this-ish. It won't ever look exactly like that. But kind of the idea is your residuals are not placed randomly like these are. You get this pattern when looking this, which is called patterned residuals. Kind of makes sense. Patterned, I don't know if I spelled that right, residuals. And it indicates nonlinear regression. Maybe appropriate. For our class, that's the end. We don't do nonlinear regression, so this is just noting that maybe linear regression wasn't a great idea. Really what's going on there is you end up with a, I kind of want to draw the picture. Sure, why not? What's going on there is maybe your observations fell something like this. Doesn't look like, stop doing that. Doesn't look like they fall linearly. It looks like maybe they're falling more exponentially. Is kind of the growth curve going on here. If we try to fit this with the least squared regression line, maybe it looks something like that. So your first few observations are above the line, then a bunch are below, and then a few are above again. So in this case, you can try to fit it with the least squared regression line, but it doesn't look like it's linear data, so it doesn't make sense to try to fit it with the line. So the idea is maybe you wouldn't be able to see it in this context, but when you look at your residuals, you see this pattern, and you're like, all right, maybe I shouldn't be using linear regression. Maybe I should be using non-linear regression. Maybe rather than trying to find a line that fits this data, I should try to find a curve that fits this data. Fine. We don't know how to do it in this class, so that's the end, just kind of recognizing that. The other thing we're looking for is called heteroskedasticity. Kind of a crazy name. What it means is that you have non-constant variance. And the idea there is that your residual plot will look more like this. You got a bunch of observations that are close to the line early on, but then later on they kind of start to spread all over the place. You get them way down, far from the line. So maybe it looks something like this. This indicates you got heteroskedasticity going on. And all you need to know about heteroskedasticity is since the variance is getting really big when your x values are big, the line isn't a great predictor anymore when your x values are big. So just be a little bit careful if you're using this line to make predictions for large x values. That's what heteroskedasticity means. So I don't know. That probably deserves a little bit more time, but this video is getting kind of long. So maybe I'll wrap it up at this point. But there's some information on the residuals of a least squared regression line. I guess that's all I got.